Very good morning, class. In the previous video, we have covered a very important topic from the machines, that was pulley. As I told you that pulley is divided into two categories. First is fixed pulley and second is movable pulley. So we have seen that in the fixed pulley, the axis of rotation is fixed. That means does not move with the load. That was a fixed pulley. In the fixed pulley, we have calculated the mechanical advantage and the velocity ratio as well as the efficiency. So we have seen theoretically, right? Identically, the mechanical advantage of the fixed pulley was 1. Velocity ratio was 1, and that is why efficiency was 100%. But I told you that practically it is not possible to have one mechanical advantage because there is some mass of the pulley is there, some friction between the axle of the pulley is there, and that is why we have to apply a bit more effort than the load. Today we will discuss the next category of pulley, which is movable pulley. As the name implies, movable. In the fixed pulley, the axis of rotation of pulley was fixed. That was the stationary. But in this case, the axis of the pulley is in motion. It is movable. So in this case, the axis of rotation of pulley is not stationary. It is in the motion, right? Now, how does it move and how this movable pulley looks like? To understand this, let's quickly see this animated video. So in the case of fixed pulley, the force is acting on the opposite side to the load, and it's quite easier to apply the force in this direction. In this case of movable pulley, you can see the force is acting on upwards. The pulley is not tied to any beam or bar. You can see that. That means the axis of rotation is movable. Only other string is fixed on the bar, and the other end in our hand to apply the effort. This is the pulley and the axis of pulley, and the load is connected directly to the pulley. This way the weight of the object is shared between the fixed bar and the person pulling it. Now we can apply the effort and overcome the load which is tied on the pulley. So load moves in the direction of force applied. So that's how the movable pulley works. So must have get an idea how this movable pulley works. You've seen that in the movable pulley, the axis of rotation is not fixed. As you can see in this diagram also, it is not supported with any rigid bar or rigid support. But one end of the string is supported at the rigid bar, and the other end of the string is used to apply the effort. Basically, this category of pulley is much more important than the previous case, than from the fixed pulley, because from this pulley we can overcome the load by applying less amount of effort. So to see this, let's see what is the mechanical advantage, what is the velocity ratio, and what is the efficiency of a single movable pulley. So we are calculating the mechanical advantage, the velocity ratio, and the efficiency of single movable pulley, right? Now to calculate the mechanical advantage, let's see the diagram. So we are calculating the mechanical advantage. To find the mechanical advantage, we must have the value of load and the value of effort, because MA is load upon effort. So from the diagram you can see that the tension acting on the complete string is T. I told you that if the string is common, then throughout the string the value of tension remain same. So if it's acting T here, there will be T also here. Now load is load is acting downwards, so it is the direction of load L. Now where we should apply the effort to overcome this load? Obviously we will apply the effort here, right? Now let's, from this diagram, let's make the equations. Okay, so from this diagram you can see that the effort acting on the system is basically equal to the tension in the string, that is T. This is your first equation. Second, load. Now this is load. You can see that this is load L, and load is supported by tension on the either side of the strings. First T is here and another T is here. So load is supported by two tensions. That means load is equals to twice of T. Equation number 2. Right? So now we have value of load, we have the value of effort, we can find the mechanical advantage. So when you solve it, mechanical advantage, that is nothing but load upon effort. So load is basically 2T and effort is basically T, so it will equals to 2. The mechanical advantage of single movable pulley is 2. What does it mean? It means that if you want to overcome the load of 100 Newton, then you have to apply only half of the force. That means you can overcome the load of 100 Newton by applying only 50 Newton of effort. That means the single movable pulley works as a force multiplier. Because force is being multiplied, we are just applying the 50 Newton force, 50 Newton effort, but it is overcoming the 100 Newton load. So this single movable pulley works as a force multiplier. Okay, I'm writing a note here. Single movable pulley work as a force multiplier. Alright, this works as a force multiplier. Let's calculate the velocity ratio of the single movable pulley. What is the velocity ratio? Velocity ratio is basically distance covered by the effort per unit distance covered by the load, dE upon dL. Now understand, this is a very important concept here. So now we are calculating the velocity ratio. Suppose you are applying some effort on this side and effort is moved by distance x. Now how this distance x move in the case of pulley and the string? Because you can see that now the pulley is not supported by any rigid support. It is free to move. So this distance x is divided equally in pulley and the other end of the string. That means this end of the pulley string will move by distance x by 2, as well as the pulley will also move the distance by x by 2, right? As you can see from the animated video, when we applying the effort from the one end, and when the effort move distance x, then this x is divided into two parts, first into the pulley and into the string, right? So this part of the string move by distance x by 2, and from the load is also x by 2. So here the distance moved by effort is basically x, but the distance moved by load is basically x by 2. So what is the velocity ratio? We know that velocity ratio is VR. It is nothing but dE upon dl. So x upon x by 2, or it is basically twice. So velocity ratio of the single movable pulley is also 2. What will be the efficiency of this pulley? We can find the from the relation mechanical advantage equals to efficiency into velocity ratio. So efficiency eta is equals to velocity ratio, equals to mechanical advantage upon velocity ratio into 100. So both the value of VR and MA is 2. So from here we'll get the velocity of the efficiency of the single movable pulley is 100%. Now there is one we can say disadvantage in the single movable pulley, that we have to apply effort upwards, and you know that the single fixed pulley is in single fixed pulley we apply the effort downwards, right? So how do we can do that? How do we can change the design of this pulley so that effort is not applied like this, but we can apply effort downwards? It's quite simple. We can just add one fixed pulley from the other end, and then we can apply the effort downwards. See how. Changing the direction of effort in movable pulley. Okay, we have the system. Right? Just add one fixed pulley here. So I have added this. This was the load here, right? Here's tension, and now we are applying effort here. So now from this case you can see that we are applying effort downwards, right? So we have changed the direction of effort. In this case we are applying effort upwards. Okay. So here we have seen the single movable pulley. Now we can use this pulley even more better way by applying a block and tackle system. Now what does it mean? Block and tackle system. It means we can add more than one pulley, more than one movable pulley in a single system by using block and tackle system. That means we can overcome a huge amount of load, even applying a small amount of effort. How we can solve it, and how the block and system block tackle system works, we'll see in the next video. Let's first see what are the main differences between the single movable pulley and the single fixed pulley, and also see, I'll show you an animated video which shows the difference between the single movable pulley and the single fixed pulley. So comparison between single fixed pulley and single movable pulley. So let's learn what are the basic comparison between them. On the left hand side you can see we have single fixed pulley, and on the right hand side we have single movable pulley. The fixed pulley is fixed at a rigid support, whereas movable pulley is not fixed to a rigid support. The load is attached to the rope in case of fixed pulley, but load is attached to the pulley wheel in case of movable pulley. The mechanical advantage of 1 in case of fixed pulley, where it is 2 in case of movable pulley. In fixed pulley, effort has to be equal to the load, but in this case, effort needs to be only half of the load in case of movable pulley. Entire load is pulled by the rope in case of fixed pulley, but in this case, entire load with pulley is supported in the middle of the rope. So pulley doesn't move up and down with the load in fixed pulley, where the pulley moves up and down with the load in case of movable pulley. It is used to change the direction of the effort in convenient direction, where in the movable pulley it is work as a force multiplier, and thus it doubles the effort. The pulley is used to raise a small load in case of fixed pulley, whereas movable pulley is used to. So thank you so much class for watching. Next video I'll make on the block and tackle system, so please don't miss that video, because if you miss that concept, how do we solve the numerical, how do we calculate the mechanical advantage or the velocity ratio of the block and tackle system, you'll find very difficult to understand it. Okay, so please keep watching the next video and try to do some numerical based on the fixed pulley system. Alright, and I'll make a video on the numerical problem on this chapter. Thank you so much class.